All right, I want to remind everybody when we go over the answers that ideally, this is where your interest is kind of peaked, right? You perk up and you're really scouring. You're looking for gold nuggets, is what I say. You're looking for mistakes, and you don't want to put little smiley faces next to every single one you got right. The only thing you want to stand out are the things that you corrected or the things that you couldn't figure out. Because then you go look at that paper later, and that's what sort of stands out. And you end up learning faster. You want to highlight your mistakes, not your successes, right? Enjoy your successes, but highlight your mistakes because that's where you're learning. That's where you didn't know how to do something and you're learning how to do something. So don't just skim this when you go over it. And I also want to reemphasize the importance of you developing as you mature as a student the the will and the bravery of asking questions. Right? A lot of sixth graders are shy and they're not that mature, and therefore they're afraid to ask questions. Okay, but that's why we're here. We'd love to re-explain something, try to explain it another way, and help you understand what we're doing. So challenge yourself. Okay. All right. This first group of problems, this will go pretty quick. We were just looking for the opposite. It's called the inverse operation. The book used the word undo, which is kind of like a computer function. Sometimes when you do something, you say, oh no, what did I just do? You can go up to the edit button, the menu, and drag down, and there's an undo. And whatever you did last, it erases it and goes back. It's like a start over, right? A do over, as kids used to say when they're playing baseball out front. All right, a do over. What was that movie? What was that? You're killing me, Smalls. Yeah, yeah, yeah. That's a good one. Anyway, what is the opposite or inverse operation of subtracting 1 2/3? Adding 1 2/3. What is the inverse operation of divide by 8? Multiply by 8. Hopefully, you make your 8 a little better than I did. What's the opposite or inverse operation of multiply by 12? The opposite is to divide by 12. Okay, that's how hard that was. We already kind of went through every step at 787, but I want to remind you, you can go to your mom, go to your dad, go to a friend who can add, subtract, multiply, and divide, and play this trick on them. They can pick any single number in the world, and whatever they pick, once you have them add 3 to it, and then multiply their answer by 3, and then subtract 3 from their answer, then divide what's left by 3, and then subtract their original number, they will always get 2. Always. That's kind of a cool trick. Okay. So you can say, I'm going to play a magic trick on you and I'm going to figure out what your number was. You don't have to know what their number was. Their number could be anything, but the answer is always going to be 2. Okay. And again, if you like that, there's more of those in the book in this section, right? There's a whole bunch of them. Okay. Starts the whole thing starts with 1, right? You pick a number, you write it down, add 5 to it, double the result, subtract 4, divide by 2, subtract the original number. What do you get? Always get the same answer. Okay. So pretty cool tricks there. All right. Let's continue on. What we left this, we had a rectangle that was 5 wide and 7 long, and we were making a new rectangle that was going to be 13 long, and we wanted to figure out how high it was supposed to be if it is proportional. Okay. And I remember you can have a baby width and a baby length. That ratio will be the same as the mommy width, mommy length, right? Or you can go small width to big width, should be the same proportion as small length to big length. Okay. What you want to always have is something that ties things together going horizontal and ties things together going vertical when you make that rectangle. Okay. What does that mean? Well, these on the top are tied together because they're from the small rectangle. These on the left side are tied together because they're both the width. These on the bottom are tied together because they are both from the large rectangle, big W, big L. And these on the right are tied together because they're both the length, the small length and the big length. Okay. You don't want to make it where you have a small W, large W, like that, and then a large L and a small L. Okay. This will not be equal. See the difference? They're not tied together here. This is a big width and a small length. They're not tied. Okay, they have to tie all the way around. So here we are. We figured out that in order to figure out how big that was going to be, okay, we had this proportion, and when we cross multiplied 5 times 13 and 7 times W, we ended up with this algebra problem. And the answer for the width was going to be 65 divided by 7. 7 goes into 65 9 times. 9 times 7 is 63. And I think I gave you the advice that don't make a decimal out of this, make a fraction. Your remainder is going to go on top, your divisor on the bottom. So this is going to be 9 and 2/7. Okay, so 2, 4, 6, 8, 9. Oh man, about as far as I can go, huh? All right, 9 and 2/7. Okay, all right. Hopefully you're able to figure that out. Let's go ahead and go to the next problem. Did we already figured that out, huh? The answer to that was the sandwiches, 5 sandwiches, 3 people, and each person gets 1 2/3, right? And we did not figure out the area of this or the perimeter. Remember the perimeter? I said you can go 20.2 plus 14. Line up that decimal. So the 4 should be, right, there's a decimal that goes there. So 34.2 gets me halfway around. I'm going to add another 34.2, get 68.4. Now, what are my units? They're not square centimeters. Perimeter is just centimeters. Okay, and then to get the area, remember the area is the base times the height, the two lines that make the right angle. So I'm going to multiply, I'm going to pretend like that's just 12 times 202. And then when I get done multiplying, now I have to figure out that how far do I have to go back in my answer. Okay, and since that was 20.2 and this was 12, it's just one place I had to move the decimal. So I go back one space in my answer. So that's 242 and 4/10. Now we're talking square centimeters for area. So there's the answers for the parallelogram. What's this shape called again? Trapezoid. What makes it a trapezoid? It has one set of parallel lines. Now these are set horizontal, but you can have a trapezoid that the two parallel lines are vertical instead. Okay, and remember, to get the area, it's not the top times the height, it's not the bottom times the height, it's the average of the top and bottom times the height. So if the top 7, the bottom 17.8, we add those together and divide by 2, that's going to get us the average of the top and the bottom. So 17 is 24, so it's going to be 24.8, and I'm going to divide that by 2, and I'm going to get 12.4. And I'm going to multiply that by 4. This is not going to be that difficult, isn't it? All right, so I go 4 times 4 is 16, carry the 1. 4 times 2 is 8 plus 1, 9, and 4 times 1. And then I'm going to go back one spot in my answer. Okay. 4, yeah, I guess that's about right, huh? Seems small, but it's this height. This says this is 4 and this is 6. Probably not drawn to scale, is it? All right, so the area of this trapezoid is 49.6 square meters. And again, to get the perimeter, I don't care about the 4. 6 and 7, that's 13. 13 and 7.5 is 20.5. 20.5 and 17.8. 13, carry the 1, 8, 38.3. And that is just going to be meters. All right. Boom, we're done. That's all she wrote. All right. Again, if any of these don't make sense, make sure you're raising your hand, asking your teacher for help. All right. Say, can you do another one like that? I don't get it. Okay. All right. Have a great day, everybody.